lesson 1.9 is on inverse functions, and we're going to do part of this note sheet today, and then we'll do the rest of it on Monday. So we're going to first just start off talking about what an inverse is and what an inverse does. So if you think of the function f of x equals x plus 2, if we were going to find f of 3, we would just take 3, plug it in for x, add 2 to it, and we would get 5. So try to think about this in a way that you think that 3 is transformed into 5. So what an inverse function would do would be to take 5 and transform it back into 3. So think for a second of a function that might do that. Take a 5 and turn it into a 3. Alright, so that function, that's the inverse of f of x equals x plus 2, is the function f inverse, that -1 means inverse, of x equals x minus 2. Okay, so the inverses we're going to find today are going to be simpler, and then on the next day that we do this, they're going to get a little more complicated, and we'll have to go through like processes to do it. But today, I think it's all ones that we can just kind of figure out in our head. So the main idea of what we're learning today is how to verify that two functions are inverses of each other. So what we're going to do is find their composition. So if you find f of f inverse of x, what happens is everything just kind of cancels away, and you're just left with x. And then it has to work the other way also. So f inverse of f of x should also give you x. All right, so on example 1, we're going to find the inverses informally. So these will just be simple functions that we can find the inverses pretty quickly. And then we're going to verify using their compositions. So we start with f of x is equal to 8x. If you start thinking like, what is the inverse of multiplying by 8? That is going to be dividing by 8. Multiplication and division are inverse operations. Okay, so that's the first part. That's finding the inverse informally. The second part, we're going to find f of f inverse of x. All right, so we're going to take the inverse and we're going to put it in to the f function. So we're going to take x over 8 and we're going to put it in for that x. So that means we are going to multiply it by 8. And when you multiply 8 times x over 8, you're just left with x. That's what we want to happen if they are inverses, if we got the right one. Okay, we have to do it the other way also. We have to take f inverse and put f of x into it. All right, so this time I'm going to take 8x and you're going to stick it in to the inverse function, which means I'm just going to divide it by 8. And when I do that, I'm just left with x. That's how you verify inverses. All right, so let's look at B. All right, so the first thing we're going to do is find the inverse of the function. So the function is x minus 1. The inverse of that is going to be x plus 1. All right, then we need to do f of f inverse. So that means we'll take what the inverse is, put it into the original. So we would subtract 1 from that inverse, and that leaves you with x, which is exactly what we needed to happen. And then don't forget, you have to do it the other way also. Take the original function and put it into the inverse. Everything I put into the inverse, I add 1 to it. So you're just left with x. All right, now example 2, definitely more complicated problems. or more complicated function. So we have f and g. So f is equal to the square root of x plus 1, but only when x is greater than 0. So the square root of x plus 1 is the quadratic function that shifted up 1, right? But we're only using half of it. We're only using the side where x is, I don't know if you'll let me just erase part of it. We're only going to use the side where x is greater than 0. So this half of it is gone. We're just using half of the graph. All right. And then g of x is the square root of x minus 1. So we want to verify that they're inverses or show that they're inverses of each other. So that means that we're going to do f of g of x. So take what g of x is, plug it in to f. So that means we're going to square it, and then we're going to add 1 to it. Now, I know that you guys are really smart, and I know you're probably going to remember that you should end up with x. And so I see, every year I teach this, I see some crazy things happen, and some magic happens, and you end up with x. Well, I don't want magic to happen. I want to see everything you do. So I want to see that the first thing you would do is square the square root, and you're just left with x minus 1. And then you bring down the plus 1. And then when you do negative 1 plus 1, you're left with x. All right, so I know a lot of you like to do things in your head, but verifying and showing are not things you can do in your head. You have to actually show it if you want to get credit for it. All right, we have to do it the other way. Also, we have to do g of f of x. So we'll take x squared plus 1, and we'll stick it in there. Now you have to follow the order of operations. The square root is not going to cancel out the square first. It won't happen that way. The first thing that would happen would be you would subtract 1 minus 1, and you'd be left with the square root of x. And the square root of x is just x. Okay, so show me your steps. Follow the order of operations. If you want to get credit for verifying, your math has to make sense. Okay, and then for the next part, we also can verify using a graph. So an inverses are reflections over the line y equals x. So if you folded your paper on that line y equals x, the f would fold right on top of g. Now, there are lots of places you guys can go to get graphs. So a free site is called Desmos. And I know a lot of you already know about this. So if you don't have your own graphing calculator and you want to know what these graphs look like, you can look at Desmos. And then some of these we can just use transformations and do it just in our head. So on example 3a, we have a cubic graph, but it's divided by 3, and then we also have a cube root. So if you want to see what that looks like, you can type it in the calculator. Let me type it in real quick. But like I said, these you can do without a calculator, just using transformations, or if you need to, you can use Desmos. Now on the graphing calculator, on this one, to get a cube root, you hit math. All right, that's the cubic, that's the cube root, and then if you want to see the line y equals x and see if it's a reflection over that line, you can. There's y equals x. So it is a reflection. So we have the cubic, all right, and then we have the cube root. I always say the cube root kind of looks like a snake. And they are a reflection over the line y equals x. So we kind of go right through them. So we would say yes, check. Oops, sorry, you guys didn't see any of that. I drew what the calculator did in different colors, and then I saw that they do reflect over the line, so it's yes. All right, so I'm going to do B without a calculator, just using transformations. So the parent function, y equals the square root of x, just looks like this. It's like half of a parabola on its side. So if I took that and I subtracted 4 on the inside, that's going to shift it to the right 4. So 1, 2, 3, 4. Boom. It would look just like that. Okay. And then for x squared plus 4, it would be a parabola shifted up 4. That's not a great graph, but and then this is another one where it's cut in half. So we only are looking at the x's that are greater than 0. So anything where the x is negative, you mark off. All right, so what it would be like would be 1, 2, 3, half of a parabola shifted up 4. All right, and then you can see those two are going to be a reflection of each other over the line y equals x. So that's yes. All right. All right, so for a function to have an inverse, it must be 1 to 1. And 1 to 1 means there's one x for each y and one y for each x. So it's 1 to 1. The x doesn't repeat and the y doesn't repeat if it's a 1 to 1 function. And so to determine if a function is 1 to 1, which means it's going to have an inverse, then you use the horizontal line test. So the vertical line test is used to test if something is a function. These we're already going to know they're functions because they're all going to be written in function notation. They are functions. We're trying to decide if they are 1 to 1 functions. And to do that, you use the horizontal line test. All right, so on example 4, it says to use the horizontal line test to determine whether the function is 1 to 1, thus has an inverse. All right, so this graph, we're going to try to do all of these without a calculator because we really don't need a calculator. So this is really a line because there is no square or cubic, there's no root, there's no absolute value. So this is a linear function. So it's really the same as 3/2 minus 1/2 x. So it's a line that has a slope of -1/2 and a y-intercept of 3/2. So it looks kind of like this. All right, so we try to see if there is a horizontal line that would ever cross this graph at more than one place. And there isn't. I don't think I can grab this and move it. I can't. I wish I could. But there isn't a horizontal line that would ever cross at more than one place. So this would be yes. So any linear function, except for one that is a horizontal line, should be 1 to 1. All right, let's look at B. So for B, we have a quadratic function. So we have x squared minus 3. So it's going to be that quadratic curve parabola looking graph that's shifted down 3. All right, would this graph pass the horizontal line test? Definitely not. There's one right there that crosses at 2 places, so we would say no. Okay, and then for this last one, this is the absolute value graph. So we would take the V graph, that's the absolute value graph, and we have +1 on the inside, so that's going to shift it to the left 1. All right, so that is what this graph looks like, and that graph is definitely going to fail the horizontal line test, so you would say no. All right, so that's how you use the horizontal line test to determine if a function is 1 to 1. Alright, I'm going to write your assignment up here. It's also in Google Classroom. You want to look at it there. So any graph that you can't just figure out in your head, go ahead and use Desmos if you have that. I mean, everybody has that. Or you can use a graphing calculator. But I'd like for you to do as many graphs as you can without looking at a graph or looking at Desmos.